In a perfect world, all of our devices, our printers and our monitors and our screens and our phones, would all be able to display and print all of the colors that the human eye can see. But they can't. In fact, not only does each device display a subset of colors, the different devices display different subsets of colors. Or to put it another way, if we think of a device as being able to represent a certain number of crayons, then different devices not only have different numbers of crayons, right? Some might only have this many while others have more, but they also have different colored crayons. So one might have just one blue while another has 5 different blues. There are many reasons that different devices display colors differently. One of them is technology. So take a screen, for example. It uses an additive process to represent color, where adding equal parts of red, green, and blue actually creates white. While as a printing technology is going to be using a subtractive color technology, where printing cyan, magenta, and yellow are going to create black. Another reason for the difference is that not all screens nor all printing technologies are created equally. So manufacturers use different materials of different qualities to meet the needs of different consumers. So keeping in mind that different devices can display different colors, we need to figure out how many colors we need to work with when creating and editing our images in Photoshop so that they can contain the colors that we want to show across all of the devices that we're outputting to. In order to do so, we're going to take a look at 4 different color spaces: sRGB, Adobe RGB, ProPhoto, and CMYK. So if we imagine that this color shape on the left here represents all of the colors visible to the human eye, of course, it doesn't, but conceptually, it's going to give us an idea of the relationship between the 4 color spaces. So here, this triangle that we can now see is representative of the RGB color space. It's a relatively small color space in comparison to the color gamut of the human eye. But most screens can display all of the colors in the sRGB color space. So it's a good color space to work in if you know that you're only going to publish to the screen. But sRGB isn't typically the best color space for editing images because most images captured by digital cameras or even phones contain far more colors than the sRGB color space. Therefore, converting to and working in the sRGB color space would most likely discard a significant number of colors in your images that you might want to work with. And with fewer colors, we don't have the headroom to make large color and tonal edits to our files without negatively impacting the quality of the image. So let's take a look at the Adobe RGB color space. This is a larger color space than sRGB, and most high-quality computer monitors can display all of the colors in Adobe RGB. It's the most popular color space because of the additional colors or headroom that we need when we make edits. And almost the entire Adobe RGB color gamut can be printed by inkjet printers, especially those with 6 or more color inks. The only drawback to working in a larger color space is that when we do convert images down into the sRGB color space to publish on screen, for example, there might be shifts in some color ranges as the image is reduced down into the smaller color space. All right, let's take a look at ProPhoto. When we look at ProPhoto, we can see that it is even larger than the Adobe RGB color space, and many people, especially photographers, work in ProPhoto to take advantage of that higher quality color data when they're processing their files. However, because the color space is so large, you might not be able to accurately see all of the colors on your screen, which may lead to surprises such as color shifts and banding when converting an image from ProPhoto into a smaller color space. We also just need to look at CMYK, so we can see that the color space used to output files to a conventional printing press is really quite limited. And while in the past some designers may have worked in the CMY color space because their work was only going to be output to a printing press, Today, it's a much less popular workflow since so much of the content that we create is repurposed for display both in print as well as on screen. To set your color space in Photoshop, we'll choose Edit and come down to the color settings. You'll notice that the working space by default is sRGB for the RGB working space. Now, if you're a photographer, then you may want to choose Adobe RGB or ProPhoto. It just really depends on your workflow. If you're designing for screen, you might want to go ahead and leave this as sRGB. So throughout the course, I'll be working in the Adobe RGB color space, meaning that all the files that I'm giving you, those exercise files, are in Adobe RGB. And you can change this here, or you can actually just leave it, because you'll notice under the color management policies, the default in Photoshop is to set them to preserve the embedded profiles. So if you are opening a file that starts in Adobe RGB, even though we're working in the sRGB color space here, the file will actually remain in Adobe RGB. And it's important to note that if you're coming from Lightroom or Lightroom Classic, the default files that Lightroom hands off is actually in the ProPhoto color space, so just be aware of that. So I'm just going to cancel out of here, and let's move to Bridge for one moment. Again, I'm going to double click on this raw file, the DNG file, to show you that you can use the hyperlink at the bottom of the preview area in order to select the color space that you want Adobe Camera Raw to hand off the file to when you decide to open that in Photoshop. So there we go, an overview of the 4 most common color spaces in Photoshop.